ओके, रिफ्रैक्शन, ठीक है। व्हाट इज रिफ्रैक्शन? रिफ्रैक्शन हलो बेंडिंग ऑफ लाइट रे। रिफ्रैक्शन होच्छिलो बेंडिंग ऑफ लाइट। नाउ why does this light ray bend? What is the reason? Reason होच्छिलो different speed of light, yes, in different media। ठीक है। Now there is a property associated with light. The property is named as optical density। Optical density। Repeat। So there are two kinds of media। So এর মধ্যে একটা মিডিয়া হচ্ছিল, one kind of media is optically denser media, আর একটা হচ্ছে optically rarer media। If the medium is optically denser, it gives more resistance to path of light। If the medium is optically rarer, it gives lesser resistance to path of light। ठीक है। Now let us take this velocity Vd as speed of light in optically denser medium, and Vr speed of light in optically rarer media। So if a medium gives more resistance to path of light, if a medium is giving more resistance to path of light, then the velocity of light will be more or less। So I can easily say that velocity of light or speed of light in optically denser medium is lesser than speed of light in optically rarer medium। ठीक है। And due to this difference in speed of light, we will be having a phenomena that is called refraction, which is basically bending of light। ठीक है, ঠিক আছে, বুঝে দিলাম। তিনাঙ্কু ডান। নেক্সট হচ্ছে, let us take two cases। Case 1, so here is a optically rarer medium, here is a optically denser medium। This is called interface between two medium। ठीक है, interface between two medium। This point is called point of incidence। In total optics, the most important part is to draw normal at point of incidence. Normal is a line perpendicular to the interface. ठीक है? So this will be the normal. So we know very well, over here the speed of light is Vr, over here the speed of light is Vd, and Vd will be less than Vr, that is Vr will be more than Vd. So when this light is travelling to this side, or rather other medium, its velocity will decrease due to the reason that this optically denser medium is giving more resistance to the path of light. Okay, more resistance. So as it is giving more resistance, whenever we are getting more resistance, what do? We try to follow an easier path. Okay, we try to follow an easier path. So light will also do the same. Light will take the shortest path. So where the light is travelling? Light is travelling in this direction. Okay. So the shortest path while going to this direction should be along the normal. Okay. So it will bend towards the normal. It will bend towards the normal to get a shorter path. Okay. Now this is angle of incidence, and this one is called angle of refraction. Now suppose this light is a electromagnetic wave. Light is a electromagnetic wave, and all electromagnetic waves are transverse waves. Transverse wave means wave which travels with formation of crests and troughs. So transverse wave travels like this. This is called crest, this is called trough, and combination of one crest and one trough is basically one wave. Combination of one crest and one trough is basically one wave. I will redraw this picture, rarer medium to denser medium. Okay. So as it is basically a wave, so we can say it is going like this. So this is how many waves? 2 waves. So let us just take an assumption that these 2 waves are passing per unit second. These 2 waves are passing per unit second. Now number of waves passing per unit time, number of waves passing per unit time is what? Thank you. Frequency, denoted by small f. So here the frequency is 2. So when this light is passing from this medium to this medium, if there are 2 waves passing, means passing through this medium, and suppose I take only one wave on this side, then what will happen to the other wave? It is going to accumulate over here. So it is like I am pumping 2 liters of water through a pipeline and you are taking just 1 liter of water. This is not possible. If I am pumping 2 liters continuously, you have to take 2 liters. Otherwise the flow will stop. So same is the case over here. So if there is 2 waves passing from in the rarer medium, there will be 2 waves going in the denser medium. How it is happening? as the light is bending towards normal, basically it has chosen a shorter path. Clear? So as it has chosen a shorter path, but it has to pass two waves, but in a short distance. So basically two waves in short distance means you have to make the waves shorter. That means, what is wavelength? This is wavelength. This is wavelength. So if I make this wave shorter, then wavelength will decrease. So here, if this is wavelength of rarer medium and this is wavelength of denser medium, then automatically wavelength of light is going to decrease. So here I can say lambda d, that is wavelength of this light in the denser medium, is lesser than wavelength of the light in rarer medium. ठीक है? Now let us bring everything together. In sound we have learned that velocity of any wave is equal to wavelength by time period. Correct? জানিস তোরা সবাই? So from here I can write it is 1 by t into lambda. What is 1 by t? So velocity is equal to f into lambda. Clear? So if this is Vr is equal to Fr lambda r, ठीक है? This is Vd is equal to Fd lambda d, ठीक है? गाना मुझे दिलाम. Now we already know that velocity in rarer medium is always more than velocity in denser medium. So I can write Fr lambda r Fd lambda d. Clear? Number of waves passing through this medium per second is 2. Number of waves passing through that medium per second is 2. So does the frequency change? So frequency does not change in refraction. Frequency does not change in refraction. Clear? So I can easily write Fr is equal to Fd. Fr is equal to Fd because number of waves passing per unit time does not change. Number of waves passing per unit time remains same. So frequency remains same in refraction. Very important sentence. ठीक है? Is this clear तो भाई? So I can easily cancel these two. Only if Fr is equal to Fd is not is equal to 0. Okay? Next. So here from I can easily write lambda r more than lambda d. Fr is equal to Fd, but they are not is equal to 0. Then only you can cancel out. So lambda r is more than lambda d. The same thing has been logically proved over here. Now it is mathematically proved over here. Clear? Okay. So this is the case when light is travelling from rarer to denser medium. So let us summarize. Light is travelling from rarer to denser medium. What happens? Light, yes, number one is light bends towards normal. Number two, if this is the angle of incidence, then this will be the angle of refraction. Angle of incidence is more than angle of refraction. ठीक? velocity of light from rarer to denser medium reduces, ঠিক বলছি তো? না না ভুল বলি, ভুল করলে আবার সেটা শুধরে নি। ভুল করা কোনো দোষ না, ভুল করে যদি শুধরে না নাও তাহলে দোষ আছে। আর ভুল করেছো বলে না ওটাই ঠিক ওটাই ঠিক, অনেকে আছে ওটাই ঠিক ওটাই ঠিক, না স্যার ওটাই ঠিক, ওটা বস্তু। ভুল করেছো মেনে নাও না, কী যায় আছে? একবার গালাগালি দেবে, দুবার গালাগালি দেবে, পরবার বলবে না ঠিক আছে ভুল তো মেনেই নিয়েছে, আর কী করবে? ঠিক আছে তো? ভেলোসিটি অফ লাইট রিডিউসেস, ক্লিয়ার? নেক্সট, what is angle of deviation? This is denoted by del, this is called del, ঠিক আছে? ये बोले angle of deviation. So angle of deviation is basically angle between incident ray and emergent ray. Clear? Now what is emergent ray? এখানে তো কোনো emergent ray আছে কি? Here there is no emergent ray. Then what is emergent ray? Emergent ray is the final ray passing out of your system. So here the emergent ray is the refracted ray. This is angle of incidence, this is angle of refraction. Now how will I calculate what is the angle of deviation? First I will extend this incident ray. Okay, and the definition of angle of deviation is angle between incident ray and the emergent ray. So angle between incident ray and emergent ray is this one. This is del. ठीक तो? This is del. Now what is this angle? Huh? This has been extended. So this angle and this angle is vertically opposite angle. So this should be I. Clear? Huh? Now del is equal to বড় অ্যাঙ্গেল মাইনাস ছোট অ্যাঙ্গেল, হ্যাঁ, I minus R, ঠিক বলছি তো? হ্যাঁ, is equal to I minus R. ঠিক আছে, প্রবলেম নেই তো কোনো? এগোচ্ছি। ওকে 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 ওকে, আচ্ছা, কেস 2, from denser medium to rarer medium. This is the angle of incidence. So here what will happen? The velocity is going to কি করে decrease by increase. Velocity is going to increase, so it is going to go away from the normal. ঠিক আছে? This is angle of refraction. ঠিক আছে? VD, VR is more than VD, so I can write FD lambda D less than FR lambda R. FD FR cancels out, lambda D less than lambda R. So important points: light bends কি হবে? Away from the normal. Light bends away from the normal. Next, velocity increases or reduces? Increases. Frequency increases or reduces? Remains same. Frequency always remains same. মানুষ বদলায় না, frequency always remains same. ঠিক আছে? না, কোনো কোনো সময় বদলায় না, ঠিক আছে, সেটাও ঠিক। হ্যাঁ, সোজা বদলাবে। আচ্ছা চলো, frequency remains same, velocity increases, wavelength, স্পিড বাড়ে না কমে? হ্যাঁ, স্পিড ইনক্রিজ করলে ওয়েভলেন্থ বাড়বে, ইনক্রিজেস। কেন এখানে ইনক্রিজ করেনি? করেছে তো, তাহলে ইনক্রিজই হবে, ওয়েভলেন্থ ইনক্রিজেস। অ্যাঙ্গেল অফ ডেভিয়েশন এক্সটেন্ড করে দাও এটাকে, ভার্টিক্যালি অপোজিট অ্যাঙ্গেল আই। সো অ্যাঙ্গেল অফ ডেভিয়েশনের ফর্মুলা কী হবে? হোয়াট উইল বি দ্য ফর্মুলা অফ অ্যাঙ্গেল অফ ডেভিয়েশন? আই মাইনাস আর, না আর মাইনাস আই, আর মাইনাস আই। আগেরটা ছিল আই মাইনাস আর না? হ্যাঁ, বলো বলো কোনটা? Emergent ray is the ray which passes out of the system. The final ray out of the system is emergent ray. Emerges out of the system. That is why it is named as emergent ray. ঠিক আছে? So in this system, the final ray passing out of the system is the refracted ray. So this is the emergent ray, and its angle with incident ray is delta. That is this angle. This will be delta, and delta will be r minus I. তুমি দেখে বুঝতে পারছো না কোন রেটা বড়? রিফ্র্যাক্টেড রে বড় নাকি ইনসিডেন্ট রে বড়? রে না, অ্যাঙ্গেল। হ্যাঁ, রিফ্র্যাক্টেড। সো আর ইজ মোর দেন আই। কেস 2 ডান। ঠিক আছে, আচ্ছা। condition of no refraction, condition of no refraction। हाँ, optical density of two medium is same. Number 2, angle of incidence is equal to 0 degree. That is, light falls normally on the interface. If the incident ray coincides with the normal, then the angle of incidence is 0 degree and light will pass straight through. মোবাইল বন্ধ, হ্যাঁ মুছে দিচ্ছি। বুঝতে পেরেছো এটা সবাই? So optical density ke if we try to convert in a physical quantity, then the term that comes out is called refractive index. So first we will run about absolute refractive index. Refractive index, in short we can call it Ri, and it is denoted by a Greek symbol known as mu. So when we talk about absolute refractive index for a medium, say for a medium M, so then there is some reference point while we take this absolute refractive index. The reference point is light must be incident from medium air or vacuum. ठीक? So this side will be air or vacuum. So air is considered completely as vacuum. ठीक है? Air and vacuum is considered equivalent. So in this case, this notation is written like this: A mu medium. So first you will write the first medium, then you will write the second medium in case of all refractive index. ठीक है? Is equal to speed of light in vacuum or air by speed of light in the medium. Now speed of light in vacuum or air is constant, 3 into 10 to the power 8, not exactly 3 into 10 to the power 8, 299 something. So we will consider 3 into 10 to the power 8, and that is denoted by C, and this is always constant, divided by speed of light in the medium is denoted by V, that is velocity of the light in that medium we are talking about. Okay. So this is absolute refractive index. Now in any case the speed of light in some medium cross the speed of light? No, because speed of light is the highest, 3 into 10 to the power 8. So absolute refractive index always has its denominator lesser than numerator, so it is always more than 1. It cannot be less than 1. Denominator cannot be higher than numerator in this case. Now when we define refractive index of any medium, refractive index of any medium like refractive index of glass, refractive index of water, any medium, we define basically absolute refractive index. So suppose I say refractive index of glass is say 1.33, that means if a light travels from air to glass, the ratio between the velocities will be 1.33 if the refractive index is 1.33. ठीक है. So any medium it can be written as C by Vm. Vm is the speed of the light in that medium. So C is always constant and Vm can be written as F lambda m. लिखा जाए तो C is constant, frequency remain constant in refraction, so this is constant. Then can I write MUM is inversely proportional to the wavelength of the medium? Can it be written? लिखा जाए तो ना कि ना? Okay. So from here I can easily say wavelength. See, this is not wavelength of the medium. This is wavelength of the light in that medium. And medium will not have wavelength, na? Wavelength of light in that medium. लिख रहा हो बेटा. Wavelength of light in that medium. ठीक है. So how does this help me? If the refractive index of a medium is more, that means the medium is optically denser. Right to na ki na? Bhavo. What is refractive index? C by V. If mu increases, C is always constant. That means definitely V is decreasing. Huh? So if the velocity is decreasing, that means the medium is getting denser and denser. Huh? So that means if mu increases, if suppose mu increases, I can easily say light will be more deviated as it passes from air to that medium. Light will be more deviated. Let us take an example to understand. Suppose this is a violet light, okay? Violet light, and this is red light, almost incident with the same angle of incidence. So this is air and this is some medium, let's take it as glass. So we know that red light has the highest wavelength, red light in visible region, that is the colors of light that we can see, visible region denoted by Vib Gear, red light will be having the highest wavelength. ठीक है? So if red light is having the highest wavelength, so for red light the refractive index will be lowest, inversely proportional. हाँ बोझा गया wavelength refractive index lowest. So red light over here is having highest wavelength, so it will have low refractive index, the deviation will be less, it will be deviated but not much, this much. What will happen to violet? Violet has much lesser wavelength, so it will have much more refractive index, so it will be deviated more, like this. So another question that can be asked from here is angle of deviation of violet light and angle of deviation of red light, which will be more? Violet light, ekdom perfect. ठीक है? So this is basically application of this one. Most of the questions in optics is related with this one. Most of the question will be related with this formula. Very important formula. Not only questions, there will be certain theory like factors affecting refractive index. Tomorrow they will be asking factors affecting lateral displacement, factors affecting angle of deviation. Everywhere this formula has some significance, because if you know that lambda r is the highest, that means mu will be lowest, that means deviation will always be lowest. ठीक है? बुझे दिलाम? पूछे दिलाम? Next is normal refractive index. So suppose it is not absolute refractive index. Suppose it is not absolute refractive index, it is normal refractive index. Now I call it relative refractive index. This has no such obligation that the incident ray has to be in air. Incident ray can be anywhere. So suppose light is passing from water to glass. So glass is a optically denser medium, it will bend towards normal. So here the refractive index notation will be like this. It is first passing through water, so water mu g is equal to speed of light in water. देखो फर्स्ट जेटा लिखबे सेटाई ऊपरे लिखबे बाय स्पीड ऑफ लाइट इन ग्लास. ठीक है? नेक्स्ट so this can also be rewritten as f. F is always constant for both the mediums, frequency will be same. So f lambda w by f lambda g. ठीक है? f cancels out, lambda w by lambda g. So by this equation also you can find out the refractive index between two media. ठीक है? So suppose I give you a problem. A mu g is equal to 5. G mu w is equal to 3. Find out A mu w. আচ্ছা দেখো এটা কি করে এগোবে. A mu g মানে কি VA by VG is equal to 5 আর এটার মানে কি VG by VW is equal to 3. ठीक. So देखो in this case I require VA by VW, I don't require G, right? This is equation 1, this is equation 2. If I multiply equation 1 with equation 2, VA by VG into VG by VW, so VG and VG cancels out, right? Is equal to 5 into 3, 15. Correct? So VA by VW already calculated 15. This is arbitrary value, this cannot be 15, but still this is for problem, nothing else. Yes.